Okay, you may start anytime you like. 5 minutes, yeah?
Yes, sir.
Good morning, Pak Dedi and friends. So today I and Anjali will be talking a bit about galvanic skin response sensor. So as we can see, this is the device that is located on the hand, and these are where the black part, which is which surrounds the finger, it is where the sensors are. Next slide. So galvanic skin response sensor, Anjali, previous slide, yeah. So it basically detects a change in an emotional response. So when we are happy or when we are sad, we produce change, and there are several changes in our eccrine sweat gland activity, and that is what causes the change in electrical ionic activity. So this sensor detects the changes in the electrical ionic activity, and the result will tell us whether we are whether we have a change in our emotion. If we are stable, then the amount will be stable. But if we are, for example, happy or sad, then maybe the intensity of the activity will increase, and from that the sensor could detect. So the sensor will not detect like what type of emotion we are having, like are we happy or are we sad, but it detects more on the intensity. Anjali, continue dari yang significant changes.
Okay, so like Tanita said before, the Gsr sensor measures the intensity of our emotion by the conductance of electrical conductance of our skin. Significant changes in Gsr activity in response to a stimulus will produce event-related skin conductance response, or called ER-SCR. The sensor works by using silver chloride contact point and the electrodes, which is the black part that we see in the previous picture. And the data is acquired with sampling rates between 1 to 10 Hertz and is measured in units of microsiemens. This is the example of the data sample that is produced. The skin conductance, which changes over time. 1%.
As we can see, there is a peak there. So it is very important for the sensor to measure this peak, because this peak indicates whether there is a change in the activity or not. So I think that's all from us. Thank you.
Okay, are there any question answered from the other group? Yeah, if not, so what is actually measuring?
The electrical activity, which is caused by the change in eccrine sweat gland.
Yeah. So the okay, what I mean is what kind of physiological phenomena is being tried to register here, to record.
So it measures the intensity of the changes in our emotions, which is shown by the eccrine sweat gland activity.
So it means, for example, when someone emotion changes, then he or she will sweat more or sweat less, something like that, based on the sweating.
Like when they're agitated or nervous.
Is it something which is physiologically or clinically proven that sweating is really related with emotional phenomena?
I think yes, but personally, maksudnya if it's me, there is a relation, like when I'm scared or when I'm agitated, then my hands start sweating a bit.
Yeah, because usually in other study it's more based on the heartbeat, for example, or on the brainwave signal. But this is something interesting to the chemical change. Yeah. Okay. Another one simple question is, so the change in eccrine sweat gland activity here is measured by the electrical ionic activity in the skin, skin conductance. It is so like that?
Yeah.
Okay. What kind of other signals inside our body that may interfere this recording of eccrine sweat gland activity? That may become noise because we are measuring the ionic activity. What do you think? Can interfere or can become noise to your sweat gland activity measurement? What kind of other noise? Okay, doesn't matter if you cannot answer now. It is something to ponder, yeah, something to look again, because like in our skin, there are many other neurons as well, right? The neurons may excite electronic activity as well, electrical activity, ionic activity as well, and may interfere with your GSR measurement. But this is interesting measurement, interesting topic. Yeah, thank you for this. Yeah, maybe next time, if you can make the whole, as I mentioned, the whole presentation just as a single slide, that will be better. Yeah, rather than just have to change that. So one slide, how does instrument look like? What kind of instrument? What kind of signal it records look like? And this, yeah, so the whole this you now become like 3 slides, right? It's too many for a
Oh,
5 presentation.
actually, two
Yeah,
slides.
actually two. Yeah, the third one is thank you, but yeah, you can make it into a single one.
Okay.
So then you don't need to change slide one to another. Okay, thank you, group 2. So
Okay,
let's
thank you,
now
Pak.
Thank you, sir.
change to group 1. One is Andi and Ezra. Bentar ya, Andi and Ezra. Andi, can you please turn on your video?
Andi bisa share screen-nya. Okay. So we will begin now. So good morning, everyone. Today we will be talking about magnetocardiography, or we can call it MCG. So next slide, Andy. MCG is a technique to measure magnetic fields that is produced by electrical currents in the heart using extremely sensitive devices. For example, a superconducting quantum interference device.
So if the magnetic field is measured using multi-channel device, so a map of magnetic field will be obtained over the chest. And from such a map, using the mathematical algorithms that take into account the conductivity structure of the torso, it is possible to locate the source of activity. Like for example, source of abnormal rhythms or arrhythmia may be located using MCG.
So the principle of MCG is how it use magnetic fields, but for ECG is use electric fields. But it produce similar signals. So as we can see in the picture here, it uses the similar signals. And this magnetocardiography or MCG is currently used to detect the baby health in the or when pregnancy, because there are a lot of pregnancy lost in the world, and sometimes it is due to the heart problems of the baby, but they cannot detect the heart of the baby using ECG, but by using MCG, they can detect it clearly also using mathematical algorithm. So um, that's all from us. Thank you.
Okay, thank you, Ezra and Andy. So yeah, again, just try to make next time. Please make it into a single slide, yeah? So that you don't need to change from such a slide. There's the title with small title at the top, and then the picture of the instrument and the principle all in one single slide, because this is supposed to be a short presentation. Okay, my question will be, what will be then the drawback or the shortcomings of MCG measurement compared to the more common electrocardiography?
Because it's use magnetic field, so um, I think it would be more there are apa sih namanya efek samping,
Side
side
effect.
effects. Yeah,
Yeah.
there are more side effects than using ECG, and also it's still there are not many people use MCG right now, so there are not many places that we can that have the tools. Jadi yeah, that's one of the um, problem right now.
Okay.
And like it is like apa, like kind of repot. As you can see, the device is like
Cumbersome.
like ada di atas. And then
so if you compare, if you know, you have already learned about the two models, yeah, of electrical signal. One is using, in this particular instrument, the signal is generated in the body, or is it from the instrument?
sorry.
It is from the instrument, and
Okay.
and then it has like similar thing like MRI, so it changes the electron direction,
Okay.
and by that it they know the signals, and then after the signals go through the body, and then the feedback signals will be catched by the sensor again, and it will produce
Okay.
signals.
So similar like MRI, similar to ultrasound, yeah, similar to X-ray.
Yeah.
Yeah. Okay. What could be the source of noise or signal interference here in this MCG case?
Actually, there are a lot of signals that can make as a noise, because our heart has a lot of signals, not just by the muscle contraction, but also from organs um, next to the heart, like lungs, and that can make a noise also for the signals.
Yeah. Okay. Final question for me: can we make such instrument ourselves?
Maybe Andy can answer it.
Oh. If we um I think gimana aja.
Possible or not
Yes,
possible?
I think it is possible, but the one of the main problem is about the price that we have to the expensive price, and yeah.
Yeah, so we cannot sir.
You mean we ourselves cannot because of the price, but if provided
Yeah.
with enough money, you may be able to
Aduh.
develop based on the principle, right?
Yeah, because these days some of the university made the smaller device,
Yeah.
not the big one. So I think
Okay.
we can apply that.
Okay. Thank you.
Actually,
Yeah.
yeah.
Grace and Anjali, do you have any questions to group one?
Sir.
No.
No. Okay. No problem. Okay. Thank you. That will be